Okay, just for a second, look around you. The chair you're in, the screen you're watching this on, maybe the walls of the room. Our whole world, I mean, everything, is defined by the materials we use. For centuries, finding new ones, materials that are stronger or lighter or more efficient, was this super slow, painstaking process. A lot of it was just luck and guesswork. But we are right at the edge of a revolution that changes literally everything. So what if instead of just finding new materials, we could actually design them, right, from the atoms up? What if you could tell a computer, hey, I need something as strong as steel but as light as plastic, and it could just spit out the recipe for how to make it? That is the incredible possibility we're going to dig into today. Now, to really get how huge of a leap this is, you got to appreciate the old way of doing things. For pretty much all of human history, materials science has been like trying to find one specific needle in a haystack the size of a galaxy. It's a massive, massive challenge. Yeah, the traditional path was this absolutely brutal cycle. First, you'd have an idea, right? A hypothesis about some new chemical combo. Then came the long, manual slog of trying to actually create it in a lab. After that, you've got all this tedious testing to see if it even works. And spoiler alert, most of the time, it didn't. So you're back to square one. This loop of trial and error could take years, sometimes even decades, for just a single breakthrough. But that entire way of thinking is being turned on its head, all thanks to artificial intelligence. AI is basically rewriting the rulebook here. It's transforming that slow, luck-based search into a fast, targeted mission. So you might be asking, how does the AI even know where to start? Well, the key is data, a huge project called the Materials Genome Initiative. The best way to think about it is like the Human Genome Project, but for stuff. It's this massive public library that details the fundamental properties of thousands of known materials, creating the perfect textbook for an AI to learn the language of matter itself. And when you put them side by side, the difference is just staggering. We are moving away from that slow, expensive, and frankly luck-based path, and we're jumping onto a fast, predictive, data-driven rocket ship. AI completely takes the guesswork out of the equation. So here's the absolute game changer. Instead of a human scientist trying maybe a few hundred combinations in a lab over a decade, an AI can simulate and predict the properties of millions of hypothetical new materials in a matter of hours. It becomes this incredibly powerful guide, pointing researchers directly to the handful of candidates that are actually worth pursuing in the real world. And look, this isn't just theory or science fiction. This acceleration is already creating real, tangible solutions for some of our planet's biggest problems. We're seeing these discoveries move from the lab and into our actual lives. One of the most urgent areas where this is making a difference is, of course, in energy and sustainability. We desperately need better materials to power our world, and, well, we need them now. The range of energy solutions being unlocked is just incredible. For example, AI is helping us find new perovskite materials to make solar cells that are hyper-efficient. It's designing materials for better batteries and energy storage. It's even working on advanced systems that can literally turn waste heat from factories back into useful electricity. The possibilities are huge, even exploring how things like graphene might one day harvest energy from the airwaves all around us. But it goes way beyond just energy. This revolution is changing the very fabric of our cities and our industries. It's affecting how we build, what we build with, and how we reuse the stuff we already have. And the applications here are just so diverse. Think about something like construction. AI is helping to create concrete that's both stronger and lighter. It's finding better ways to recycle materials, discovering powerful new magnetic alloys for things like electric motors and data storage, and even designing novel materials that are tough enough to store cryogenic rocket fuel. And this one might be the most profound of all. AI-designed materials are opening up a completely new frontier in medicine and health, creating things that can safely and smartly work inside the human body. This is where it gets really futuristic. We're talking about smart biomedical materials for 3D and even 4D printing. That means materials that can literally change their shape and adapt after they've been printed inside your body. Scientists are using AI to design custom nanomaterials from DNA itself, and it's even helping to improve medical scans for better, faster diagnoses. So when you take a step back and look at this whole picture, it's pretty clear this is way more than just a new tool. It represents a fundamental shift in how we as humans innovate and create just about anything. But there's a really important nuance here. It's not as simple as just building a powerful AI and letting it run wild. As the researchers in this field are quick to point out, finding novel materials needs more than pure machine learning. So what's the missing ingredient then? If it's not just the algorithm, what's the secret sauce that makes this whole thing work? Well, the missing ingredient, it's us. The real revolution isn't AI replacing scientists. It's about creating this incredibly powerful partnership between human creativity, asking the right questions, and that creativity being guided and amplified by the raw computational power of a machine. We provide the spark of intuition. The AI provides the horsepower to explore the entire universe of possibilities that spark creates. So we've shifted from an age of slow accidental discovery to an era of fast, intentional design. We can now actually architect the basic building blocks of our world with a speed and precision we've never had before. So the final and most important question isn't really, can we build it anymore? The question we all have to think about is, now that we can design materials at the speed of thought, what will we choose to build?